Okay, so the next test, you write along with me. It is your test 2.2, okay, 2.2B. Under your exercise 2.2 question B 3. Okay, 3, you will find this on textbook, page 38. So write likewise along with me. And I start with question B3, subheading 1. Okay, let me read the question for us. Listen carefully to it. Verify whether the following are zeros, means the solutions, zeros of the polynomial indicated against them. So number 1 is here given to us. P of x is given as 3x plus 1 with x value given as minus 1 by 3. Or rather, exactly like the text, then minus 1 by 3. Same thing only. Minus in the middle of the dash means it's on the numerator. So next here, therefore, P of x value is given as minus 1 by 3. So minus 1 by 3, let us check for that. And 3 into x therefore is minus 1 by 3 and plus here 1. So that will give you equal to, before that, bracket here means 3 is multiplied to this. So into means we can cancel 3 1s are 3 and 3 1s are 3. And plus and minus is minus. 1 by 1 is 1 only. So 1 and plus here 1. So minus 1 plus 1 is 0, right? So therefore we see that, or you can write in this format, since we see that, since we found out P of minus 1 by 3 value substituted in P of x is equal to 0 finally. Therefore we have here this one, this value x equal to minus 1 by 3 is a 0 of the given polynomial. Okay, polynomial of the given polynomial P of x. So if it is equated to 0, then that is a 0 or a solution. If it's not equal to 0, then it will not be a 0. We have to check whether the given value here, x equal to whatever it is a 0 of the given P of x or not a 0. So in this case it's a 0. And let us go to 2. Second one. So here, subheading 2, question number 3. Here, clearly given to us is P of x value is given as 5x minus pi, with x value mentioned as equal to 4 divided by 5. So we'll do now in the same manner. So I think it's quite easy. Therefore, P of x value, given that x is equal to 4 by 5, can now be replaced by P of x. So x is 4 by 5. So we put that, and here 5 into therefore x value. We replace that 4 by 5 minus pi. And we can clearly see here up and down, 2 5 and down, 5 1s are 5. 5 1s are 5 can cancel. So we're left with 4 plus 4 minus pi, which is not equal to 0. This is not equal to 0. That is, since we found out P of 4 by 5 is not equal to 0. Finally, equal to 4 minus pi means not equal to 0. Therefore, the given value here, x equal to 4 by 5, which is, we can just write 4 by 5, is not a 0 of the given polynomial. We can just shorten it now. We understand P of x. So 4 by 5 does not fit in P of x, this value, because it's not equatable to 0. Next 3. The third one. 1, 2, 3. P of x this time is equal to x square minus 1, where x value, there are double values 1 comma minus 1. So let's check for the first one. Therefore p of the first x value here 1 plus 1 will be x is now plus 1 square minus here 1. Now 1 ones are 1 only, so 1 minus 1 equal to 0. Then p of the next value, p of minus 1, when we put, then x square will become minus 1 bracket whole thing square minus x square minus 1. And we know minus 1 square means minus 1 into minus 1. If you don't want, you need not write. Okay, minus into minus plus 1. 1 ones are 1 for this. Then minus 1, 1 minus 1 is 0. So both of these are, since p of 1 and both of it, p of minus 1 both, p of 1, let's just write like this, p of 1 is equal to 0, we found out. And also p value, x value of minus 1, p of minus 1 is also equal to 0. Therefore both the numbers 1 and minus 1, x equal to 1 and minus 1, and minus 1 both are zeros, plural. There are 2 of the given polynomial p of x. So that's how we're doing it. And the fourth one. The fourth one is here. We are given the fourth one. I think p of x is given as equal to the fourth one, x plus 1 into x minus 2, where x value is given double again, minus 1 and plus 2. So we have to check for both. So let us check for the first one. Therefore p of the first x value here minus 1, and when it's minus 1, this x will therefore be minus 1 plus here 1. X is this time minus 1 minus 2. So we're going to get here minus 1 plus 1 is 0 into minus 1 minus 2 is minus 3. We know that when both are minus, we add 2 plus 1, 3, and the sign will be minus. And 0 multiplied to anything is 0. And 0 has no sign, plus and the minus we need not do, because 0 into anything is simply 0. 0 neither has plus or minus sign. And p of the next one is plus 2. Then our equation here, x is now plus 2 plus 1. Here 2 minus here, x is 2, so plus 2 minus 2. 2 plus 1 is 3. And 2 minus 2 is 0. So 3 into 0 again is 0. So since both of these values, p of minus 1 is equal to 0, and also p of plus 2 is also equal to 0. Therefore both these values, minus 1 comma plus 2 given here in the question, are actually zeros of the given polynomial p of x. Then the fifth one. So here the fifth one is question number 3. Fifth one. Let me read the question for us. P of x. Here the p of x value is given as equal to x squared for x value of 0. So we can write here, therefore p of x value is 0, so we put there in place of x 0. X squared, therefore 0 square, and 0 square is simply 0. So since we found out p of 0 just now is exactly equal to 0, therefore 0 is a 0 of p of x. Yes, I think that's correct. Yes. Great. So far all yes, I think. Yes, then the sixth one. Yes, yes, and also yes. fifth and the sixth one. So let's go to the sixth one. So here the sixth one is here. P of x value is given as sixth one lx plus m for a value of x equal to minus m by l. Minus m by l. This is minus, okay. So therefore the p of minus m by l, because the x value is minus m by l, will be now x is going to be replaced by this one minus m by l plus here m itself. Up L and down L can cancel, so we're left with plus and minus minus m, and here plus m. Minus m plus m is 0. So we can write here now, since this p of the value x value minus m by l is exactly equal to 0, therefore minus m divided by l is actually a 0 of the number p of x. 5, 6, okay, 6. This is 6th, then 7, we go to 7th. So here the p of x value is given as 3x squared minus 1 for a value of x equal to, two values are there, minus 1 by root 3 comma and plus 2 by root 3, I think. Yes. So let's just start for the first one. P of the first value of x when it's minus 1 by root 3. And this here 3 into x will be replaced by this minus 1 by root 3 square. So the whole thing square bracket must be there. Minus 1 is equal to, yes, 3 into here minus square means minus 1 into minus 1, so minus into minus plus, so minus 1 square is plus 1 divided by root 3 square means root 3 into root 3 2 times, which is equal to 3. So down here will be 3, root 3 square 3, so that's covered. Minus 1, minus square is always plus, right? And 3 ones are 3, 3 ones are 3, so this is leaving you with 1 ones are 1, minus 1 equal to 0. And we have to try for the next one. When the p value is 2 by p of 2 by root 3 here, the same value here 3 into 2 by root 3 will replace this x, so x square means 2 by root 3 whole square minus 1, and that will give you 3 into, now 2 square is 2 2s are 4 divided by root 3 square is root 3 into root 3, 3 root removed, here minus 1, so this 3 up and down cancel, so you're left with 4 here minus 1, which is plus 3. So our answer for this one will be here. Our answer will be, therefore, since p of first value, p of minus 1 by root 3 is actually equal to 0. Therefore, this value minus 1 by root 3 is a 0 of the given polynomial p of x, which is this one, 3x squared minus 1. And the next second value here, and p of 2 by root 3, the second value, is not equal to 0. You can write here equal to 3 means not equal to 0 if you want. Therefore, the value here 2 by root 3 is not a 0 of p of x. So the first one is a 0, second one 2 by root 3 is not a 0. Okay. Then once we're through with that, let's go to the 8th one. Okay, 8th one. I think I missed out on number 2, if I'm not wrong. So let us go back to number 2. Maybe I have not missed out. Even if I've missed out, let me repeat it. Number 8 first, let me do. Okay, so here Number 8 is, here the p of x value is given as equal to 3x squared minus 1 for an x value of sorry, p of x value is not this one, number 8, the last one. 2x plus 1, sorry, 2x plus 1 for a value of x equal to 1 by 2. So therefore the p of the x value here is 1 by 2. So when x is 1 by 2, this x will be replaced by 1 by 2 plus 1. So this 2 and 2 cancel, so we're left with 1 plus 1 equal to 2, which is not equal to 0. Therefore p of 1 by 2 is not equal to 0. Or you can write here since p of x is not equal to 0, p of 1 by 2 is not equal to 0, sorry, 1 by 2 is not a 0 of the given polynomial p of x. Okay, I'm not sure whether I missed out 2 or done, so let's just repeat it. If I've already done, well and good. If I've missed out, then we'll be doing it now. So subheading 2. Here given to you p of x equal to 5x minus pi, 5x minus pi for a value of x equal to 4 by 5. Right, so therefore p of the particular x value is 4 by 5. Maybe I've done into x is here 4 by 5 minus pi. So this 5 and 5 cancel. Then 4 minus, I think we've done pi, which is not equal to 0. So since p of 4 by 5 is not equal to 0, therefore this value 4 by 5 is not, I think we've done, not a 0 of the given polynomial p of x. Simple enough, right? So I hope you got it. That concludes the part for test 2.2b. Okay.